In this video, we're going to practice finding the domain and the range of a function. Now, the graph of a function, we'll call it f, is the collection of ordered pairs x, comma, f of x. Now, if you remember from some of my other videos, we talked about how f of x is like y, right? It's our output that we're getting. So don't freak out when you see f of x in there. It just means what was the y value, okay? So x is going to be in the domain of our function, okay? So as we go through the following section, remember that geometric interpretations of x and f of x, like what do they mean? So let's take a look. So we draw a coordinate plane here. X is the direct distance from the y-axis. So we're going this way and we're going this way, right? And our f of x is going to be the distance from the x-axis, right? So as we look at this, we see that this is x and that this is f of x or y. Probably should put an equal there, or y, right? But the brackets won't work. Let's try that, like y. So we're going to use the domain, the graph. Sorry, we use the graph of our function f here, okay, of our function f, to find the domain and to find the values f of 0 and f of 3, and then the range of f. So if we look at our graph here, we see it comes up. We have an open circle there. We're going to come up through the top, closed circle, coming back down, closed circle, and down, right? Now the domain of f is what are the things that x is allowed to be. So for example, if I said that x was 1, could I find an answer on my line? I sure could. What if I said if x is -2? Could I find an answer? Sure I could. There it is. Now remember that this graph keeps going, and it grows and it grows. It's getting longer and longer. And if we were able to go out to infinity, it would just keep stretching out and out. Okay? So really, this is kind of like all real numbers, except that we have this open dot right here. We have this open, and this means that there is a hole in our function. Here it is telling us that when x equals 3, or -3 rather, that -3 is not in our domain. So if our graph had arrows on the bottom like this, we would write all real numbers except when x equals -3. But if we go back and we look a little bit more carefully at our first graph, before we put our arrows on, there were just endpoints there, right? There were no arrows. So that indicated an end of our function, our end of our function, okay? So this tells us that our domain is going to be including -4 to -3, but it doesn't include -3. And then it's going to go from -3 all the way over to +3, and it includes +3. So by putting our parentheses here, we're showing that there's an opening, or that there is a hole there. So our domain are all of the x's in -4, comma -3, in close bracket -4, comma -3, and open bracket -3 to +3, close bracket. So next, we're going to take our equation, and we want to know what is f of 0. So to find f of 0, we're going to go to where x equals 0. So we're going to go to where x equals 0 and go up to our spot on our graph. And here we see that f of 0 equals 3. Our output is a 3 there. The spot on the function is 3 when x equals 0. And now we're going to look for f of 3. So we're going to go on our graph, we're going to go to where f is 3, and we're going to go to our function. And here we see that when f is 3, our function value is a -6, or that y value is a -6. So our domain finds everything that x is allowed to be, but our range finds all the things that y is allowed to be. So here we're going to be talking about all the f of x's, right, or the y's in, and if we look, we have a base value of -8, so it goes all the way down to -8, and it comes all the way up here to 3. And it does everything in between, except there's a hole, right? There's a hole. We know where the hole is at, except the hole. But this time, instead of focusing on the -3, because we're dealing with the y's, we're going to focus on that -6. So we're going to have a closed interval, and we're going to look at our hole. All right, so we're going to have a closed interval, and we're going to look at our hole because I want you to see something. Yes, we have a hole, and that right here, that's a -6 where the hole is at. But if we come over here, that -6 has a place. So even though the x might not exist at that hole, the y does. But instead of being a -3 or a 3, it's just the +3. So we won't be writing down the -6 or any hole. We'll simply have the closed interval from -8 to +3. So the range is anything inside of that closed interval. And again, we know that it's closed because if we look down here at our endpoints, we didn't have open holes there. And up here at our maximum, there wasn't an open hole there either.